All right, you guys, now we're going to graph exponential functions, okay? So the function we've been asked to graph this time is f of x equals 2 to the x power, okay? So the first thing I want you guys to get in the habit of doing is identifying what your base is. So in this problem, my base is 2, okay? So remember, your base tells you whether or not you're going to be dealing with a growth graph or a decay graph, okay? Because my base is greater than 1, okay, that means I'm going to have a growth graph, which means that as I'm looking at my graph moving from left to right, it should be increasing, okay, which is why our graph is moving from left to right. It's increasing, okay? And all of your transformation rules that you guys have learned before, they still apply now, even though we have exponential functions. So we'll see that this graph has no horizontal shift, it has no vertical shift, any of that, okay? So if they were to ask you to graph this by hand, the easiest way to do it would be to plot points, all right? So as you see, they've created this table, all right, where they've tested a bunch of x values. They've plugged the x values into the function, all right, to get your y values, and then they've graphed them. Okay, so that's our first one. All right, our second graph, okay, they want us to graph f of x equals 2 to the negative x minus 3 and determine the domain, range, and horizontal asymptote of f, okay? So for this one, okay, you want to identify your base. Your base is still 2, which means that you're dealing with a growth model, okay, which is this first picture. All right, they've got a growth model, okay? Now this negative x here, okay, that's a reflection. So how about I do this for you guys? F of x equals 2 negative x minus 3, okay? The 2 lets me know that this is a growth model. This negative x tells me this is going to be a reflection, okay, about the y-axis. Okay, so don't forget your transformation rules, which is why in this picture, you'll see that our graph has flipped across the y-axis, okay? And this negative 3, okay, you guys know that that is a vertical shift, okay? And since it's negative, we follow the sign. This tells us to move our graph down 3 units. And you'll see that this graph has moved 3 units down, okay? All right, so remember, you can always plot points and you can always use your transformations to graph the appropriate graph, okay? Now let's answer the other questions. They want to know what the domain, the range, and the horizontal asymptote of f is, okay? So the domain are your x values, okay? So for this exponential function, all right, our domain is always going to be negative infinity to positive infinity, all reals, okay? For our range, remember your range is your y values, okay? So our range is all the way from, can you spot it? It would be from negative 3, it would be a parentheses, all the way to positive infinity. All right, and then our horizontal asymptote, okay? Remember, normally your horizontal asymptote is at y equals 0, but because our graph shifted down 3 units, it's now at y equals negative 3. Okay, so any vertical shift is going to affect your horizontal asymptote, okay? So if you want to keep that in mind, vertical shifts, okay, are going to affect your horizontal asymptotes. So your vertical shifts are either going to move your horizontal asymptotes either up or down from their original position, okay? All right. Let's look at the number e. Okay, so you're going to see e a lot when you're dealing with your exponential functions. So it says many problems that occur in nature require the use of an exponential function whose base is a certain irrational number symbolized by the letter e. So e for us is 2.71281828459045. It's a non-ending decimal, okay? You do have an e button on your calculator, so I don't expect you guys to memorize the number, okay? And for those of you going on to calculus, you will become more familiar with this definition. So it says that the number e is defined as the number that the expression 1 plus 1 over n to the nth power approaches as n approaches infinity. And in calculus, this is expressed using limit notation. So it says e equals the limit as n approaches infinity of 1 plus 1 over n to the nth power. Okay? So what this means is that n goes to infinity. That means n gets really, really big. As n continues to grow, they said that this quantity, okay, the limit equals e. Okay, so you guys don't have to worry about deriving this definition for me or the formula or understanding that. I just need you guys to know that e is approximately this number, okay, and that we will use it a lot. So remember that it's about 2.718 and it's positive. So when you guys see it in an exponential function, okay, e is now our base, okay? So remember, e is about 2.718, okay? So its graph looks like a growth model, okay? It looks like a growth model because remember, if its base is 2.718, its base is greater than 1. So it looks like a growth model, okay? Cool.